charged particle moving in a uniform electric field. Let us say that there is an electric field in the y direction. This is x, this is y. Let us say there is an uniform electric field in the y direction of strength E. E is the field strength. A positively charged particle having charge q and mass m enter at the origin. This is the origin. At the origin with velocity v in the x direction. That means here a charged particle just entered. Charged particle of mass m, charge q and velocity v. V, initial velocity, is in the x direction. Is there any force acting on the charged particle in the x direction?
No, sir.
No. Because electric field is in the y direction. There is no component of electric field along x direction. So, in x direction, the force on the charged particle is 0. Clear? That means Fx is 0. But as it enters in the region of the electric field, it experiences a force along y direction. Right? It experiences a force along y direction. Since there is an electric field along y direction, electric field E means charge on plus 1 is E. Therefore, charge on Q is Q into E. That means force along y direction is Q into E. If there is a force, then there will be acceleration. This force will accelerate the charge in the y direction. Therefore, acceleration along y direction is Fy by m. That means Qe divided by m is the acceleration along y direction. And this acceleration is fixed. Since Q is fixed, m is constant and E is also constant throughout the region. Since E is uniform. If E is not uniform, then the Ay will be changed or acceleration will change. But our discussion is on the uniform electric field. So this acceleration is constant. But since Fx is equal to 0, therefore x is equal to 0. Let us say the particle is moving for t second. The charged particle is moving for t second. Then in t second, the charged particle moves along the x direction, as well as along the y direction, and the displacement along x direction is x is equal to v into t, because v remains constant along y direction because there is no force along x direction. So along x direction velocity will be uniform, that is there is no acceleration, so displacement is equal to velocity into time, or you can say t is equal to x by v. But if in time interval t the displacement along y direction is y, then y can be written as ut plus half at square. But u, which is the initial velocity along y direction, is 0. So therefore you can write 0 into t plus half a is qe by m into t square. Therefore we can write y is equal to qe by 2m into t square. Just replace t by x by v. Therefore we get y is equal to e by m into t is x by v whole square. Therefore we get e into x square divided by 2m into v square. Or you can write y is equal to e by 2mv square into x square. Now see here, this is constant term. Because E is electronic charge, capital E is the uniform electric field strength, m is the mass of the charged particle, and v is the initial velocity along y direction. Right? Therefore, you can say y is proportional to x square, or you can say this is an equation of a parabola. That means trajectory of the particle is parabolic, or the charged particle will move in a parabolic path. Therefore, the path will be like this. Path will be like this. If the particle reaches this point at time interval t, then this distance is x and this distance is y, and the relation between y and x is this, which is the equation of a parabola. Hence, the path of the particle will be parabolic.